Welcome to our next video. We'll be talking about the dividend discount model-based approach. We have a dividend, D index 1, in the first period. Say this dividend might be $10 in year 1. And we have a growth rate. The dividend may grow with a growth rate of G, say 20%. The growth rate might be 20%, which means that the dividend will grow from $10 in year 1 to $12 in year 2. And it will grow again to $14.40 in year 3, and so on and so on. You always multiply with 1.2 to get the new dividends. That's the growth rate. That's the meaning of growth rate, 20% here in this example. And now the cost of capital might be equal to 30%. So you want to divide those numbers to get the value, to get the net present value of those numbers, of those dividends. And you need to divide $10 in year 1 to get the value of $10 of year 1. To get it, to change it to year 0, you need to divide $10 by 1.3. And you need to divide $12 by 1.3 squared, and so on and so on. $14.40 divided by 1.3 to the power of 3, and so on. And this will again give us a result of $100. So the net present value of all those numbers, of all those dividends having grown with 20% equals 100. How come? Because we know a different formula. We know this formula that gives us the result of a dividend growing with a growth rate of G and with a cost of capital of R, index E. So we need to just put in the number of the dividend of the first year, $10. And we need to divide by 0.3, the cost of capital, minus the growth rate, which means $10 divided by 0.1, that gives us $100. So again, if there is a dividend that is not constant over the years, but that will grow with a growth rate of G, and if we have the cost of capital, we can just calculate the present value, or let's better say the net present value of those dividends in year 0, of course, is equal to this very formula that gives us $100. Thank you for watching.